So let's have the attendance later. Malinaw naman. Okay. So Zener diode circuit. So Zener diode. So actually there are 3 primary lessons here. Pero yung first one muna, the basics, and then yung part 2, so we'll have it on Tuesday. So may klase pa tayo sa Tuesday. But then madali lang na tayo mag-klase. Maximum of 1 hour. Kasi pagdating ng January, pagdating ng January, you only have 2 weeks left per lecture and 1 week for term test. Term test na, but pagdating ng January 18, eh, meron pa tayong lecture na Tuesday, so we can have the exam pagdating ng January 5, and we still have enough time to finish. Okay, ano ko muna. Mahina yung ano, signal ko. Hello. Ayan. Nagpa-bad quality. Okay. We'll still have lecture January 22, yung kasunod nito, in the second, part 2 of Zener diode. Then we'll have the unit exam by Tuesday. And then, mag-upload din ako ng activity number 3. Yan. I-upload ko lang din sa MS Teams. By the way, kumusta ang activity number 2 nyo? Okay naman.
Ma'am Jane?
Yeah.
Sorry po, ano po ulit yung mga dates to take down namin? Bale, this Tuesday po, meron pa po tayong class, tama po?
January 5. I-move natin January 5 yung unit exam.
January 5 po ang unit exam.
Yung first Tuesday. Or basta that week. So if you want to beg off, basta that week.
Okay
7 siguro. Friday. If not Tuesday, Friday. Okay, basta.
Ay, sige po. Yung ano po, yung sa January 22 po, yes.
18. Term test na. Term test na natin yung week na yun. Kaya,
January 18 po ang
kaya, ang bilis, no? Yan. Kaya, mag-iwan ako ng assignment, yung activity number 3 about Zener diode na yun. And then, after this Zener diode, we still have one topic left. Actually, transistor introduction and mga circuits. Circuitry na transistor. Yan. Selected DC circuits about transistor. Kaya kailangan lang nating tapusin yung topic natin this December. Okay, but then I'm trying hard to make it as easy as possible, simple as possible, okay? Okay, saan ba tayo? Can we start? Question pa? Do you have any question pa? Okay, so this is recorded. So good evening. So welcome to Applied Electronics. So our topic for today is about Zener diode. So
Ma'am, yung sa activity po, paano po yung sa video?
Again?
Ma'am, yung sa ano po natin activity, paano po i-upload po yung video? Saan po i-upload?
Ay, sa FB na lang yung video. Create kayo na FB, please. Short video lang.
Ma'am, hindi po ba sa ano? Sa PowerPoint? Parang pwede pong mag-attach ng video sa PowerPoint.
Kaya lang, hindi lahat nga nakakapag-attach sa sa MS Teams. Kaya mag-create na lang din. Yung mga hindi makapag-attach siya, ang naka-attach lang dapat sa PowerPoint, picture na lang. Pero yung video sa FB, mas madaling mag-upload kasi sa FB. Yung nasa MS Teams, pictures lang, kahit 1 or 2 pictures only, which is called out from the video. Galing din sa video. Ganun na lang.
Ma'am,
Yeah.
nag-upload po ako ng video sa MS Teams po. Okay lang po yun?
Okay lang. Oh.
Okay po.
Hello.
Thank you po.
Pero next time,
Okay lang po
kasi yung
kayo
iba
sa...
talaga, may mga issues talaga sa MS Teams. Mas madali kasi mag-upload sa FB. Pwede ba kayo magawa ng closed group, FB? FB.
Meron na po tayo, ma'am?
Sa section niyo lang?
Yes po.
Sa Applied Electronics din?
Yes po.
Okay. Member na ako noon.
Yes, ma'am. Admin na po din kayo.
Oo nga, no? Oo nga, nakalimutan ko. Ayan, daming concerns, no? Ayan, nakalimutan ko. Anyway, thank you. Ayan, i-review ko lang. I-review ko lang yun. Kasi sa anong subject ko sa kabila? Digital electronics ko, ganun din. No? They're doing the experiment at home. So, they document it. So, nag-video sila. And then, they upload it at FB. Sa MS Teams kasi maraming issues. Minsan, masasubmit ka dun. Basta maraming issues ang MS Teams eh. But then, MS Teams is the official platform. Kaya we have to use it for documentation para everything is official. Official kasi yung MS Teams. Kaya MS Teams and G Suite. Yung iba siguro ng G Suite. Okay? Yan. Concern pa. Yan. Pwede naman mag-submit kahit late. May deductions lang. Okay? But then if you're having technical issues, PM nyo lang ako. Okay? Question? Question pa? Okay, wala na. Start na tayo. Shall we start? Pwede na mag-start? Okay, so again, good evening. Okay, so we have our new topic, Zener diode. So, yan, experiment nyo, 1 and 2. So, it's ordinary diode or rectifier diode. So, we have a Zener diode. Ito naman is another kind of diode, Zener diode. Pangatlong diode na nga pala ito, no? Because the second one is LED. Light emitting diode, but then the rectifier diode and light emitting diode only works in forward bias. And dito lang nag-work ang si LED and the rectifier diode. It only works at forward bias. Pag reverse bias, anong reaction ng ating diode? What happened?
Open circuit na.
Okay, so it approaches open circuit, diba? So, yung LED natin at saka yung rectifier diode, so it only operates on forward bias. So, pagdating ng 0.7, so on siya. Below 0.7 off. But Zener diode is unique because it conducts both in positive and negative, both in forward and reverse bias. Okay? May tatawag tayong VZ. Pag it is connected in reverse bias, so the voltage across the Zener diode is equal to VZ. So here, almost the same symbol as the ordinary diode as the rectifier diode. It's just that letter Z, no? Parang letter Z yung ating cathode. So to signify that it is Zener diode. How it looks like? It looks like basically the same as the ordinary diode. Kung lalo na pag block yung ano niya, yung body niya. So hindi mo mapapansin kung at hindi mo mabasa yung number, hindi mo mapapansin kung if it is a rectifier diode or Zener diode. So basically the same. So, meron pa rin siyang silver band to signify na siya yung cathode. Okay? But then, may mga nabibili din ang Zener diode usually is glass. May mga glass na Zener diode. Pag glass yung body niya, yung cathode niya is normally a black band. Black naman yung band niya. So kung saan yung black band, that is the cathode. Okay? So Zener diode works in both forward and reverse bias. If it is connected in forward bias, so it exhibits the same characteristic as the ordinary diode. So you'll be able to measure 0.7 across Zener diode. But if it is connected in reverse bias, so you'll be able to measure the voltage across equal to Vz. So since Zener diode talaga is usually used in reverse bias. Yan. Reverse bias talaga siya. It is normally used as a voltage regulator. And here are some of the Zener voltage range. So it could be, sample lang to kasi hanggang ano pa lang siya, listahan niya 22. But it could be as high as a few hundreds of volts. From a few voltage here. So example is we have 1N4728A, which is 3.3 volts. Okay. So yan yung value ng part number ng diode. Example dito is from 3.3 to 22 Vz to. And ano pang makikita natin dito? Wala siyang binanggit na PZ. Yan. Pero may binanggit siya na IZM, maximum Zener current. So you just multiply the Vz times IZM. So that would be your PZ, or maximum power dissipated by the transistor. Okay? Ayan. Okay. Let's have an example here. So ito muna yung lecture natin for tonight. Fixed input voltage and load resistor. So, as you can see here, how is the diode connected with respect to the supply? Connected ba siya forward or reverse bias?
Reverse po.
Reverse, okay? Reverse bias siya. Because that is the usual application of Zener, no? The Zener is again employed or used usually in reverse bias para mag-exhibit siya ng voltage equal to 10 volts. Kasi pag ginamit mo siya in forward bias, so parang gumamit ka lang ng ordinary rectifier diode. And parang sayang lang kasi Zener diode costs more than the rectifier diode. Okay? So Zener again is usually employed in a circuit in reverse bias. So reverse bias siya. So example here, solve for VL, VZ. VL is voltage across load resistor. So we have load resistor here, RL. RS, series resistances or input resistance. Then you have the Zener here, which has a value of bibili ka sa tindahan, yan. Pabili po ng 10 volts Zener, yan. Yan, ganun sasabihin mo sa tindahan. Yan, Zener voltage, 10 volts yan. And then let's say it has a characteristic of 30 milliwatts, yan. PZM. And then the input is 16 volts. Yan. So how are we going to know if the Zener is, we have to check if the Zener is on or off. Okay? So, yung Zener dito, hindi pa na natin masabi kung active siya or kung on or off. Okay? So, how are we going to know if it is on? If it is on, if the voltage across RL, kasi what is, let's say we don't have a Zener diode here. Halimbawa, wala tayong Zener diode dito. How is RS and RL connected? How are they connected? Anong connections ni RS and RL?
Series po.
Okay, they're connected in series. Okay? They're connected in series. Thank you. Yan. Connected in series. And to be able to determine what is the voltage across RL. So we use this, ano ba tong formula na to, if you can still remember. Voltage across series circuit. So we may use, this is actually a voltage divider principle. Okay, so this formula here. Okay. By voltage divider principle. Okay, by voltage divider, so the voltage across RL is RL over RS plus RL times the input. So if VL, okay, so this is just an initial test. If VL is greater or equal than VZ, then VZ is on. Otherwise, it is off. Okay, so we have to test if the voltage across RL would be enough to turn on or to activate the Zener diode here. So applying the formula, so we have VL is equal to 1K over 1K plus 1K times 16. So 1/2 times 16, so we'll have 8 volts. Okay, so ano daw yung VZ dito? VZ is 10, whereas the computed value is for voltage across RL is 8. So since VL is less than VZ, then Zener diode is off. So ano mangyayari pag off si diode? So it will assume ano nangyari? Off kasi diode eh. Ano nangyari kay diode? Nag-assume siya na
Current is 0. Open circuit.
yan, no. Yan, current is 0 because Zener diode assumes an open circuit. Open circuit siya kasi yung voltage across RL is not enough to activate the Zener diode. Okay? Kasi the Zener voltage rating ng Zener diode is 10 volts whereas the voltage na nag-build up sa RL is only 8 volts. So it's not enough. So since Zener is off, it assumes sa open circuit thus IZ is 0. Kasi nga, bakit nga ba 0 yung IC pag may open circuit? Bakit nga ba? Bakit pag open circuit, automatic 0 yung current?
Wala pong flow.
Ayun, no, walang flow, no, yan. Tama, yan. Just a simple, ano lang, no? Simple explanation, simple analogy. Walang flow, putol, yan. Parang tulay, no? Hindi makatawid yung mga tao kasi putol. Putol ang tulay. Yan. Walang flow. Kaya IZ is 0. So, kung walang flow kasi ang Zener natin sa open circuit, therefore, ano na yung magiging overall circuit natin dito? It looks like ano na? Wala nang Zener, di ba? Kasi open circuit siya. How is RS, RL, and BN connected? Ang tawag na sa circuit na yan?
Series circuit.
Series po.
So it's just the circuit becomes an ordinary series circuit. So alam natin pag ang series circuit, what is the characteristic of a series circuit? Ano yung constant sa series circuit?
Current.
Okay, so we have current equal. That's why IS is equal to IL. Yan. Kasi kung anong dadaan kay RS, bakit nga ba equal sa series? Yan. Wala na siyang ibang dadaanan eh, di ba? Si IS, pagdaan kay RS, hindi naman siya pwedeng lumiko dyan kasi nga putol yung putol. Yan. Kaya dito, lahat ng dumaan kay RS, dadaan din lahat kay RL. Okay? So that's why the current in a series circuit are equal. And ano pa? Question? None so far? Okay, so we can use Kirchhoff's voltage law. Ayan. Ngayon ko lang nalaman na double H pala to, no? Ngayon ko lang talaga nalaman. Okay, using Kirchhoff's voltage law, yan. Where insufficient voltage is 0. Kasi pwede tayo mag-loop dyan, di ba? Tama ba? Hello? Pwede ba tayo mag-loop? Pwede ba?
Yes, ma'am, kung naka-series po siya.
Pwede, di ba?
Yes po.
Yan. So, we have, starting from input, so, yung battery, yung longer, this is positive, this is negative, tama? Yung sign ng battery, okay? So, lalabas sa positive, okay? Kaya positive V in, and then, pag same direction current and the flow, anong assumption natin? What is this sign? This is the flow, this is direction of the loop and direction of the current. If it is same direction, so anong sign natin? Plus, minus?
Minus.
Okay, minus. Okay, that's why we have a minus here. Minus ISRS, and then, ayan, tapos na tayo sa ISRS. So, dito na tayo sa RL. So, again, same direction of the loop and the current. So, we have, the sign is, anong sign? Same direction. Same direction of the loop and the current. So we assume, ano assumption natin siya? Negative. Okay, so still negative. Minus ILRL. And then back to the supply. Kaya equal to 0 na siya. Okay, but IS is equal to IL because they are actually connected in series circuit. So we can factor out IS. So V in minus IS times RS plus RL is equal to 0. So therefore, the current flowing through the circuit is simply equal to V in over the sum of the resistances. Ayan. Okay, so anong value nun? Teka lang, hindi ko yata siya kinuha, no? Anong value nito? Compute natin. Bakit di ko siya kinuha? 16 volts divided by 2K. 2K is equal to ilan? 8. Anong sagot nyo?
8,
2K.
8 milliamperes.
Okay, 8 milliampere. Okay, so we have 8 milliampere. Ayan. So therefore, by Ohm's law, VS, ISRS, this is actually Ohm's law, di ba? Tama ba? Class? Ohm's law?
Yes, ma'am. Opo.
Okay. Wherein V is equal to IR. Ayan. Mabagal ba o okay lang? Question? Ayan. By Ohm's law, V is equal to IR. So we have VS equal to ISRS. So we have 8 milliampere times 1K. So 1K yan, di ba? So we'll have 8 volts. Okay. So of course, same here. IS equal to IS equal to IL. So this is also 8 milliampere times 1K. So we have 8 volts also. Tama ba? Tama ba, class? And what would be your VZ equal to VL2? Open si Zener, di ba? Physically, hindi natin siya tinanggal. Pero, ano kaya magiging VZ natin dito? Let's say, maglalagay tayo ng tester dito, VOM, voltmeter. We put the positive here and the negative here. What do you think would be the expected VZ equal to?
16.
16? Yung iba?
Volts po, ma'am, yung kukunin po.
VZ. What would be the expected VZ? The Zener is actually there. It's just that ang assumption natin is that it is an open circuit. Tama ba? Ibalik natin. Nandiyan pa rin naman actually yung Zener. Kaya lang, the assumption is that IZ is 0 because Zener is in reverse. Zener is off. Tama? But then, if you're going to measure, so off na si Zener dito, di ba? But then, and because Zener is off, so it assumes an open circuit. Tama ba? Okay, but then if we're going to measure voltage across Zener diode, so what do you think will be the voltage across Zener diode? Open circuit siya, di ba? Open circuit. Sige lang, hula lang kayo. Kahit anong, okay lang, tatanggapin ko lahat ng sagot nyo. That's how we learn, di ba?
8, ma'am.
8, okay. 8 volts. Bakit siya 8?
Kasi dumaan na po siya sa RS and RL pa rin.
Okay. Iba pang opinion.
Naghati po yung dalawang resistor.
Yes, and then?
Kaya po naging 8.
Tama yun. Tama yung 8. Pero bakit siya 8?
Nahati po yung current, ma'am. Dadaan sa kabila, tapos dadaan din sa kanya.
0 ang current across Zener kasi open siya, di ba? Yan. Oo, nilagay ko lang ulit yung Zener doon just to show na it's always there. It's just that it is off because the voltage across RL is not enough to turn on the Zener diode. But yes, 8 volts is correct.
Dalawa po kasi ma'am yung resistor. Naghati po yung current na nag-flow.
There's nothing, wala nga current na nagpo-flow sa Zener kasi nga open circuit siya. Pero tama yung 8. Okay? Sirit na. Okay. So, open siya. Open si Zener. But then, it is connected. How is it connected with RL?
Parallel.
Parallel. And what is constant in a parallel circuit?
Voltage.
Okay, voltage. Okay, so as you can see, yan, tanggalin natin si Zener. Okay? Yan. Kunwari may Zener pa rin dyan. But then, ang approximation natin is that Zener is off, di ba? Tama ba? Zener is off. But then if you're going to put the positive here, using voltmeter, and the negative here, you're actually measuring the voltage across RL. Tama ba? Kasi kahit na dito ka mag-measure, positive dito, negative dito, you're actually measuring the voltage across RL. Pero pag nag-measure ka dito, positive and negative, you're practically just measuring the voltage across RL. Okay? Question? Nag-gets nga ba? Hello? Question?
Okay po ma'am. Kasi po nakaparallel po yung RL. Kaya po 8 din ang lumabas. Pero kung sa dulo, kung doon po mag-measure sa may sa may RS po, tapos makukuha yung 16 po.
Hindi ko nakuha yung tanong mo. Hindi ko nakuha yung tanong mo. Sorry Ayan. Yan. Parallel kasi si Zener kay RL. Okay? So that's why your VZ is equal to VL. So we have, this is, ano ba to? 8 volts. Yan. Kaya 8 volts din siya. Question? Okay na? Okay, so what is the power across Zener diode? So, since wala naman talagang current na nag-flow through Zener diode, so VZ, using power formula VI, okay, but then your IZ is 0, so power is also equal to 0. 0 what? Question? Question? Question for number 1. Okay. Question for number 1 before we proceed to number 2. Malinaw na number 1? Hello?
Yes po.
Yes, ma'am.
Okay. Ayan. Okay, so this would be our last example for fixed in a diode circuit. Ayan. So we have example number 2. So mapansin, iniba ko natin. Ito lang yung nagbago, no? RL is 3K. 3 kilo ohm. So, ano kaya mangyayari? Okay? So, same pa rin. So, we use the voltage divider principle to determine if Zener is on and off. So, you really have to do this initially for fixed input voltage and load resistor. Yan. You have to do that initially to determine the state of Zener diode if it is on or off. Okay, so since RL is now equal to 3K, so 3 over 1 plus 3, so 3/4 times 16. So we have VL is 12 volts. So initially, the voltage across RL is 3 volts. And the Zener voltage is only 10 volts. So since VL is greater than VZ, then therefore we can be sure of that Zener is on. So naka-on talaga si Zener dito. So kung on na si Zener, so the VZ will assume equal to 10 volts. So mag-activate si VZ. Mag-activate si VZ and the voltage across the Zener diode would be equal to 10 volts. So kahit na ilan kahit umabot pa ng gano'n ka, 20 or higher pa yung VL natin. Once that you've reached the VZ, so mag-activate si VZ, kung ano man yung VZ rating niya, and take note. So this is cathode, but reverse yung sign niya. So the cathode becomes positive and the anode becomes negative. So yan ang characteristic ni diode. Zener diode. Okay? So take note, reverse yung ating polarity. Question? Question? Okay na? Walang tanong? Okay. Ayan. Then, next. Okay. So, alam na natin that Zener is on. Oh. Same lang. Okay. So, alam natin that Zener is on. So, therefore, we can be sure of na meron ng current na nag-flow kay Zener. Okay. So, since Zener diode is on, so ang circuit natin is not just simply equal to series circuit, but rather it becomes, ano na ang circuit natin?
Series parallel po.
Ayan, series parallel na. Because we now have Zener in parallel with RL, and this RL and Zener combination is in series with RS. Tama? So it becomes series parallel circuits. Okay? So as you can see here, with respect to junction A, so this is the current IS. Okay, magsasanga na yung current natin. So some of the current will flow through Zener and some of the current will flow through IL. Ayan, parang parang tulay lang yan, saan kadadaan. Ayan. May mamimili dito, may dederecho. May kakanan, may dederecho. Ayan. But then, pagdating sa junction na to, magjo-join na naman yan. Yung IZ and IL, magsasama ulit to become IS again here. Okay? So since Zener diode is on, the circuit becomes a series parallel circuit, and furthermore, VZ is equal to 10 volts. 10 volts wherein yung cathode mo naging positive. Okay? Positive na yan. And okay. Reverse yung sign, no? So the cathode becomes positive and the anode becomes negative. Okay? And then, since Zener is activated, so ang magiging voltage ni RL would be equal to VZ na. Yan. Bakit? Bakit naging equal to VZ si RL? Si VL. The voltage across RL becomes equal to VZ. Bakit?
Parallel.
Okay, because they're connected in parallel. Okay? So, since parallel sila, and VZ is on, so since VZ is 10 volts, so therefore VL is also equal to 10 volts. Okay? And then to compute for IL, so we may use Ohm's law. Yan, para malaman natin si IL, gamitin natin ang Ohm's law. So we have IL is equal to V over R. Ayan, VL is 10 over RL of 3K. So we have 3.33 milliampere. Tama ba to? Ayan, we have 3.33 milliampere. So yan, matatanda yung mga Ohm's law, Kirchhoff voltage law, Kirchhoff current law mamaya. Ayan. Question. Baka may question kayo with respect to this slide. Question? Wala?
Doon po sa
Sige.
Doon po sa kabilang slide po, bakit po naging 12 volts po yung VL, ma'am?
Testing lang yun. Okay, we have to test whether Zener is on or off. So this is the first step. Yan, para malaman mo kung active, kung on or off si Zener. Just like here. Okay, balik tayo sa number 1 ha. Balik tayo sa number 1. Ayan. Ayan, di ba? So, we have this. RL is 1K. So, basically, we have the same circuit. Okay. But then, we don't know if Zener is on or off. Okay. So, kaya nag-testing tayo. So, we test the Zener if it is on or off using voltage divider principle. And by voltage divider principle, we found out that the voltage across RL is just equal to 8 volts, whereas the Zener voltage is equal to 10 volts. So, yung voltage across RL would not be enough to turn on the Zener diode. Okay? Kaya, na-assume natin dito kanina, kaya ang assumption natin kanina is that the Zener is off. And if Zener is off, it assumes an open circuit. So, pag open circuit siya, so it's like, ganyan, disconnected siya. Okay. Electrically. But then, in physically, nandiyan pa rin yung Zener. Yan. So, since Zener diode is off, it assumes an open circuit. Kaya walang IZ na mag-flow through the Zener diode. Kaya, ang ending nito is it becomes a simple series circuit. That is for number 1. Kasi off si Zener dito, kaya siya open circuit. But then for number 2, here comes number 2. Saan na ako? Okay. Here comes number 2. Take note, binago natin yung value ni RL. So the RL now becomes 3K. Basically, same circuit, ang nagbago lang is the value of RL, di ba? So, with RL equal to 3K, we don't know yet if Zener is on or off. Okay? So, that's why nag-test tayo using voltage divider principle. And we found out that with RL equal to 3K, so the value of VL would be equal to 12 volts. And the value of VZ is just equal to 10 volts. So if VL is equal to or greater than VZ, then VZ is on. So this time with RL is equal to 3K, we can be sure of that Zener is indeed on. Yun lang naman ang gusto natin malaman eh. Kung on ba ang Zener or off siya. So magiging on lang si Zener if the voltage across RL is equal or greater than VC. Okay? Naintindihan nyo ba, class? So it's okay to ask because even in face-to-face, this is a confusing subject. No more so, naka-online lang tayo. Clear na? Okay? So since VL here, based on initial computation, VL is 12 volts. So we can be sure that Zener is active on. So kaya hindi natin siya pwedeng tanggalin sa ano, okay? Hindi natin pwede assume that VZ is open circuit. So Zener is on, so we can be sure that merong IZ na mag-flow sa Zener. Yan. Hindi sira yung tulay, makakatawid tayo. Yan. Makakatawid tayo across Zener diode. And since on si Zener, okay, active siya, and ang specs ni Zener is that it is equal to 10 volts. Ayan. Kung 10 volts si Zener, and Zener is connected in parallel with RL, kaya ang voltage across RL is also equal saan?
10 volts po.
10 volts also. So, inadapt naman niya ngayon yung voltage across Zener. Kasi on si Zener, and Zener is 10 volts, so the voltage across RL is also equal to 10 volts. Okay? And now, to compute for our IL, load current, okay, so we may use simple Ohm's law. Yan, Ohm's law na lang. Okay? And the Ohm's law is equal to V is equal to IR. Yan, mga basic equations sa mga electrical circuits, but very useful. Yan, si Ohm's law, si voltage divider, current divider, Kirchhoff's voltage law, and Kirchhoff's current law. So, parang dyan lang din umiikot ang mundo. Yan, basta na mo yon. Yan, madali na lang. Kahit yun na lang din halos yung alamin mo. Okay, so using Ohm's law, so we can determine the load current equal to 10 volts over 3K is equal to 3.33 milliampere. So, ang nagpo-flow ng current daw through RL is equal to 3.33 milliampere. Okay. So, meron na tayong sagot for IL. May sagot na rin tayo for VZ and VL. Tama ba? Ang sagot natin kay VZ?
10 volts.
10. VL is?
10.
10 din. And IL is?
3.33.
3.33 milliampere. So, tatlo. 1, 2, 3, 4. So, may 4 pang natitira. Yan, may makulit na pusa. Okay, sana tayo. So may IL na tayo, 3.33. So paano natin malalaman si IS? Ayan, dapat alamin muna natin si VS. Okay. Ayan. So maglulup tayo. Okay. Maglulup tayo dito. Ito lang. Ayan, dito. So starting from V-in, so we have V-in, lumabas sa positive kaya positive. And then voltage across RS, same direction current and the loop. So sign is, ano ba?
Negative po.
Ayan, minus. Okay, minus ISRS or minus VS. And for Zener, kasi Zener in reverse bias, ayan. Ano na ba? Dumaan na kay RS. So, ano na sunod? Pagdating kay Zener, saan lumabas?
Negative.
Yan. Yan. Minus PC. Yan. Kasi sabi nga natin, if Zener is on, so reverse yung reversing polarity niya. So the cathode becomes positive and the anode becomes negative. So that's why it is minus VZ here. And then back na siya sa supply is equal to 0. So therefore, Vs is equal to yan, 16 minus 10. So we have 6 volts. Okay, and then what else? So with Vs of 6 volts, so we can now compute for series current. So 6 volts over 1K is equal to 6 milliampere. So kanina, this is 3.33. We have 6 milliampere here. So at junction A, so we may solve for IZ using Kirchhoff's current law. Yan. At junction A. Okay, so pag current law naman, KCL, so yung pumasok positive, yung lumabas negative. So this is basically IS minus IZ minus IL is equal to 0. Okay, so yan. Yan, ito yun. Okay, so junction A, yan, junction A, IS minus IZ minus IL is equal to 0. So therefore, IZ is equal to IS minus IL. May value na tayo ni IS, so we have 6 milliampere minus 3.33 milliampere. So IZ is equal to 2.67 milliampere. Okay. Ano pa? Okay. So, meron na tayong IS, IZ, IL. So, PZ na lang, ano? So, with IZ equal to 6.67 milliampere, alamin naman natin kung kakayanin ba ni Zener yung, kasi you have the maximum BZM, maximum specs ni maximum power that the Zener can handle is only 30 milliwatts. So hanggang 30 milliwatts lang yung kaya niya. With 6.67 milliampere flowing through Zener, so what would be the power flow? What would be the power consumption ni Zener? So we have VI. With power is equal to VI, so we have 26.67 milliwatt, which is lower than 30 milliwatts. So, hindi naman puputok si Zener. But then, usually, okay, so in a practical circuit, so if you have 30 milliwatt, so dapat makakalahati lang, mga 15 milliwatt in practice, okay? But in computation, so this should, computation, kaya pa naman niya, but then in actual, dapat half lang yan. Half lang yung value. Otherwise, iinit na rin sobra yan, di ba? Ayan. Yung mga nagbo-blow up, yung mga pumuputok na capacitor, pumuputok na, wala pa namang pumutok na Zener diode so far. So, diode is basically, matibay talaga ang diode. Mapa-rectifier, mapa-Zener. Wala pa namang pumuputok na device na ganyan. Okay? So, hanggang dyan lang muna tayo. Yan. Focus, yan. Kasi this is still ang introductory subject. So, mahirap naman na ibuhos natin lahat. Ayan. Any question? Hindi pa ako nakapag-upload ng seatwork. So, I will upload siguro after January. After Tuesday, pahinga muna kayo. Pagkatapos itong Zener na to, mag-upload ako ng assignment and activity. Yan. Circuit using the Zener diode. Okay? Question?
Ma'am, question po.
Yes, question.
Next week din po yung unit test po.
Hindi, January na.
Ay, January na po. Kala ko next week
Oo,
na.
kasi may part 2 pa siya eh. Hindi ko pa... Ito,
Okay
may
po.
2 topic. So, I only introduce this. Ito naman is variable RL na. Yan. Yeah, meron na siyang RL. So, ito naman, di pa tapos eh. Tsaka, ito naman, variable input. So, ang tanong naman dito is, what would be the value of RL? Yan, yung RL min, RL max. So, gagamit kayo ng potentiometer. Yan, potentiometer. And dito naman is variable input. Yan, hindi natin siguro ito magagawa in actual. But then, you will compute kung ano yung minimum input voltage and maximum input voltage. Kasi, fix lang yung battery nyo, di ba? So, ang lalagay na natin supply dito is 9 volts. So, alamin nyo ano yung, what would be the value ng potentiometer na pwede in RLR. RL mean minimum resistor, minimum resistance and maximum resistance. So, gagamit kayo most probably ng potentiometer here. Ayan. If you want to. Pero kung hindi nyo makapa, edi mag-compute kayo ng fixed resistances. Ayun. Yan. Actually, mahirap. This is a new topic. Yan. Kaya dinadahan-dahan ko. Ano. Yan. Kasi nakakalito talaga itong topic na ito. Question. Malinaw ba? By the way, before I forget, let's have the honorary attendance. Can you turn on your cam, please? Ayan. Sabay ba kayo sa work?
Bahay lang
Bahay
po.
po. Sa biyahe po.
Sa biyahe. Ayan. May naka-face mask, ibig sabihin nasa office kayo?
Office, ma'am. Opo.
Okay.
Office po.
Sige. Okay. Pwede na? Okay. 5, 4, 3, 2, smile. Ayan, may umabol pa. Sige lang. Ayan. Isa pa. Okay, isa pa. Okay, baka biglang mawala yung signal natin. 1, 2, 3, 4, smile. Okay. Ayan, ayan. O, kasama ka, di ba? Ayan, laki ng face mask mo. Ayan. That's all for tonight. So, I'll stop the recording now. Okay ba yung lecture natin ngayon? Do you have any question? None? Okay, so recording is being stopped.